So in this question, you're given that A capital N is the set containing AN where N belongs to natural numbers. So what is the meaning of this? So AN is nothing but a set containing the elements of the form A into N where N belongs to natural numbers. So N is equal to 1, 2, 3, so on. So what is A into N? A into 1, A into 2, A into 3, A into 4, A into 5, so on. It is A, 2A, 3A, so on. That is, AN denotes the multiples of A. Multiples of number A. Similarly, Bn denotes B into N where N belongs to natural numbers. So N is equal to 1 gives B, N is equal to 2 gives 2B, N is equal to 3 gives 3B, so on. So B, 2B, 3B, so on. That are multiples of B. And Cn denotes C, 2C, 3C, so on. These are nothing but multiples of C. So AN denotes multiples of A, BN denotes multiples of B, Cn denotes multiples of C. Now, you're given that A, B, C are three natural numbers and B and C are co-primes. Co-primes means that B and C do not have any common factors except one. B and C do not have any common factors except one. That's the meaning of B and C being co-primes. Right? Now, you're given that Bn intersection Cn. Bn intersection Cn. So Bn is the multiples of B, Cn is the multiples of C. So what is the intersection of these two? So we know that the intersection of these two will be the LCM of B, C, N, right? Because if you take the multiples of 2 and the multiples of 3, if you take B as 2 and C as 3, Bn denotes the multiples of 2, Cn denotes the multiples of 3. So what are the common elements present in these two? The common elements are the multiples of 6. The multiples of 6 are there in 2n as well as 3n. So if you have to intersect Bn and Cn, you need to take the LCM of B and C of n. Because B and C are co-primes, the LCM of B and C is nothing but BC of BC of n. And this is given as Dn. This implies D has to be equal to BC. So do you understand why LCM of B and C is B into C directly? Because B and C do not have any common factors. So HCF of B, C is equal to 1. And in 10th class you have learned that LCM of BC into HCF of BC is equal to B into C. HCF is 1, so LCM has to be equal to BC. Hence, D has to be equal to B into C. So option C is the right option. So in this question you are given that N of A is equal to 200, N of B is equal to 300. And N of A intersection B is equal to 100. You're asked to find N of A complement intersection B complement. So from these three informations, finding N of A union B is very straightforward. N of A union B is N of A plus N of B minus N of A intersection B. That is 200 plus 300 minus 100, which is equal to 400. So does this have anything to do with this question? Yes, because you know that A in complement intersection B complement is A union B whole complement. A union B whole complement. So N of A complement intersection B complement is N of A union B whole complement, that is equal to number of elements in universal set minus n of A union B. So now, sorry, you're given, so I have misinformed the question. So in this question, you're given that n of A complement intersection B complement is equal to 300. If so, n of U is equal to how much? That's the question. So if n of A complement intersection B complement has to be equal to 300, how many elements should universal set have? So if that is the question, this implies n of A union B whole complement is equal to n of U minus n of U minus n of A union B is 400 is nothing but n of A complement intersection B complement, right? N of A complement intersection B complement is 300, which is equal to this, which is equal to this minus this. This implies n of U has to be equal to 400 plus 300 is 700. That means there should be 700 elements in the universal set. Now let us go to the next question.